Hello and welcome to this video on the discriminant and roots. So you were asked to work through this assignment in advance on the discriminant, and it says that when a quadratic equation is written in the form ax squared plus bx plus c equals 0, then the value of b squared minus 4ac, which we recognise from the quadratic formula, is called the discriminant. And of course that could be positive, negative or 0, and that will determine how many possible solutions there are for your quadratic equation. So just going through them, a, b squared minus 4ac was 24, b it was negative 23, c it was 0, d it was 33, e was negative 80, f was 49, and g was 84. Question 2 asks us which of the 7 equations from question 1 has no real roots, having told us that that occurs when we have a negative discriminant, i.e. b squared minus 4ac is less than 0. And that is true for B and E, which had values of negative 23 and negative 80. Notice down the right hand side that I have written when things have one root or two roots as well. You will get one root when B squared minus 4ac is 0, because you're square rooting 0 and getting the same answer. But you'll get two roots, or two distinct roots most of the time, if your B squared minus 4ac is positive, like it is in A, for example. I once made up this analogy for roots, which I've described as the worst analogy in the world, but bear with me, I'll just quickly talk you through it. So just imagine that the ground is b squared minus 4ac, and we're planting a seed. So the first seed has been planted below the ground. It's getting no sunlight and it has no roots. Obviously that's not true biologically, but it's nothing happening. There are no roots, it can't see the sun. Our next seed is getting a bit of sunlight because it's poking out of the soil, and it has one root. So b squared minus 4ac is 0, and there's one root. And then finally, we have to suspend our belief and imagine that we've planted a seed above the ground. Okay, as a result of that, the seed got lots of sunlight, and you can see that it has sprouted two roots. So b squared minus 4ac is positive, and there are two roots. So in summary, depending on whether or not b squared minus 4ac is negative, equal to 0, or greater than 0, we will get no roots, one root, or two roots. If there are no roots, then as we know, it does not intersect or meet the x-axis. If it's got one root, then it is meeting the x-axis at that single point. And if it's got two roots, then it's intersecting the x-axis at 2 points. Typically, questions on this topic will give you a quadratic equation with an unknown like k in it. And then depending on how many roots there are, you will need to use one of the conditions. So working from top to bottom, if there are two distinct real roots, then that means that b squared minus 4ac is positive. It can't be equal to 0, because if it was, there'd only be 1. If there are two equal real roots, or one root exactly, as you might call that, then b squared minus 4ac is equal to 0. If there are no real roots, then b squared minus 4ac is less than 0. If it just says there are two real roots, then they could either be distinct or equal, in which case b squared minus 4ac is greater or equal to 0. This is question 3 from the preparation assignment, which may have confused you a bit, but here are the ideas. So we have this quadratic equation, which has k in it, and we're told that there are no real roots. So that means that b squared minus 4ac is less than 0. If we substitute in b as k plus 5, a as 3 and c as k plus 14, and put that less than 0, then by a bit of rearranging and simplifying, we get that k squared minus 2k minus 143 is less than 0, which factorizes to k minus 13, k plus 11 is less than 0. Now, you met quadratic inequalities at GCSE, and that informs us that the critical values are negative 11 and 13, and because it's less than 0, k must lie between negative 11 and 13. Take a quick look at 3 examples. So y equals x squared plus 8x plus 19 has no roots because b squared minus 4ac is negative 12, which is of course less than 0. And note that we could write that by completing the square as x plus 4 squared plus 3, which we know has a minimum value of 3 and therefore can never be negative and hence does not have any roots. Y equals x squared plus 10x plus 25 has one root because b squared minus 4ac is 0. If you factorize it, you get the same answer twice of negative 5, which therefore shows that it meets the x-axis at a single point. And if you work out the discriminant for x squared plus 7x plus 12, you get 1, which is greater than 0, hence that has two roots. And if you factorize it, you get x plus 4, x plus 3, which has values of -4 and -3. And then to finish off, 3 examples where we're told an equation in terms of k and how many roots it has, and therefore we have to determine the value of k. So for kx squared plus kx plus 3 is 0. Note it says k can't be 0, because if it was, then 3 will equal 0. Find the value of k. So 2 equal roots, or 1 root only, same thing, implies that b squared minus 4ac is equal to 0. Substituting in, we get k squared minus 12k is 0, which factorizes to k minus 12 equals 0. From the equation, k is 0 or 12, but we do know that k can't be 0, hence the answer is 12, and 12 only. 2x squared plus k minus 3x plus 2 equals 0 has no roots. Find the set or sets of values for k. So no roots means that b squared minus 4ac is less than 0. Substituting b as k minus 3, a as 2, and c as 2, we end up with k minus 3 squared is less than 16. We could rearrange that and factorize it if we wished, but basically that means that k minus 3 critical values is either 4 or -4. So our critical values are 7 and -1. So k is going to be between -1 and 7 because it's a negative inequality. And then finally, 4x squared plus k plus 2x plus k equals 1. The first thing you would need to do is to take away 1 from both sides because it needs to equal 0. So a is 4, b is k plus 2, and c is k minus 1. Find the set or sets of values for k. So substituting into b squared minus 4ac, again remembering that c is k minus 1, we end up with k squared minus 12k plus 20 is greater than 0, which factorizes to k minus 2, k minus 10 is greater than 0, and solving a positive inequality that gives us that k is either less than 2 or k is greater than 10. Thank you for listening.